Hey, the last video was running a bit long, so I've split it into two. So picking up from the last one, look at the middleware. So this part looks just at the code involved in the middleware, and then we go on and look at the added component to my Angular client to create the config file. Now I'm looking at the middleware I set up. So this is middleware between Cloud IOT and Firebase Firestore. So the way basically the Angular client or management client communicates and transfers information to and from Cloud IOT. I think I went through this at the architectural level in an earlier video, but these are all implemented as Firebase or in the end Google Cloud functions. So looking at the functions that have been set up, and I'll go into the code for these after this overview, but the various functions are this one here, measurements on publish. So every time a measurement gets published in Cloud IoT, so it basically receives a measurement from one of the devices, then this function gets called, and this actually just copies the measurement over to the Firestore database, so building up our collection of measurements. So having a direct copy of what's getting published over in Firestore. So that's the activity going from IoT to Firestore. So these other functions here, or most of the other functions, these ones here, device update, device create, those handle changes in the Firestore information about devices. So when I do things like create a new device, update the information about that device, these functions get called, and then I look at the detailed code to see what Cloud IoT API gets called to perform the updates that are now needed in Cloud IoT, so it reflects what's in Firestore. And then finally this function here, hourly function, this is a cron job. So at the moment it's set up to run every hour. So the first minute of every hour it fires, and inside there I've actually calling two functions depending on whether it's the first hour of the day. I'll call a daily summarize function. Otherwise every hour it just does an hourly summarize. So this is looking at all the measurements that were collected over the last hour or the last day and create summary records for it. So I'm not using a time series database. There's not one available natively in Firebase anyway, so I got around that by kind of creating my own implementation of a time series database. So using Firestore, it's creating the summary data, so it's taking the detailed measurements and summarizing it for each hour, and also summarizing it for each day in a time series that can be used for doing the data visualizations down in the Angular client. So in the next video I'll start working on some of these data visualizations, but this gets me the data for doing that put together. So again, I'll go through some of the code for this hourly function and the summarize function that it calls for hourly summaries and daily summaries on the measurements. And that's about it. User create was just a function that I had in the starter application. So basically when you create a new user, it just puts a server time date stamp on it as the create date for that user, but is not unique to the ourProbes application. So let's start having a look at the code. Okay, let's have a look at the functions. First, let's have a look at the function that waits until IoT publishes a measurement and sends that information to Firestore, to the measurements data store. So let's go to let's go to index first. So this is the top level function. I've commented out a bunch of code in here that I used for testing some of the functions. So this is basically what it'll look like when it's in production without the comments. So measurement on publish is in the measurements file. So this is the measurements file. So here's the measurements on publish. It uses a pub/sub functionality. So on the topic measurements, so that's the name of the pub/sub topic that IoT sends the incoming probe data to. So when it gets an on publish trigger, so every time a measurement comes into Cloud IoT, it performs this function. So it's setting up a measurement object here, which is made up of a value, a probe ID, the current the time measured on the measurement happened, the device ID, and type. So it just initializes all those. Then it goes through for the message JSON coming into this function. It's getting the value that's coming in from the pub/sub topic event. It's getting the probe ID. It's getting the UMT value coming from the measurement, so the time that the measurement happened down on the device, not the time that this is publishing the information over to Firestore. The device ID, so this comes from the actual message attributes, because it is still keeping track of the device that's publishing this message, and the type. So another change down on with the refactoring was there can be different measurement types. So again, a Bing probe can create both a real-time round-trip latency and a bits per second measurement. So the type reflects what the measurement actually is for. And then finally it just adds that measurement to the Cloud Firestore measurements structure. And that's it. And if we go over here to our probes and look at the database and look at the measurements data store, there's probably thousands of measurements in here, but you can see the format of the document in Cloud Firestore. Now for updating the devices in Cloud IoT, it's based on triggers over the device's Cloud Firestore database document. So see an example here. So device on create, so this is in the devices file. So device create function is the function created when a document in devices collection is created. There's an async process, and down here we're basically collecting the information from the document that was created on the Firestore side of things. So getting the snap information here, so the public key and the communication, and it's going to try adding the device, which is this function down here, otherwise comes out with errors. And you'll see I've added this middleware event function. So in middleware events, this is just a general way I can record things that happen or things that shouldn't happen in middleware events. So if there's any errors creating or updating a device, it actually writes the information about what the error was out to middleware events collection. There shouldn't be any of these, but this is a way I can keep an eye on things when updates are happening through the Angular client. Really not much point giving the user information about middleware failures, so instead I record them to this middleware events log in the Cloud Firestore, so I can look there if anything bad has happened. Going back to devices, so like I said, the onCreate calls this add device function here, which is defined down here, and this is where it's communicating with the IoT API, and I've got some links in here that show examples from Google documentation, what this is all based on, but basically sets up the IoT client. So this is the object that represents Device Manager client that I'm going to be working with to create the devices. Brings in the registry path, so information about what project, what cloud region, what the registry ID is, and I store that centrally so I don't have to keep re-entering it in every function. And then I set up the object that defines the device that we're creating, so ID is coming from here, public key is coming from input here, which was one of the Firestore document fields, and whether the communication is blocked or not. And then it returns IoT client create result, which is returned as a promise and gets managed here. So like, again, if it fails, then it records the error to middleware events. So next up, we'll look at the on update. So device on update on the Firestore side of things can cause two actions. So either we're updating things to do with the actual device or things to do with the device configuration. And that's what this first part of the code in the on update trigger does. So gets the before and after image of the device in Firestore, checks to see whether it's just the communication flag or the public key has changed, in which case we're going to do an update to the actual device information, so it calls the update device. Otherwise, if we make changes to the governance seconds or the probes that are associated with that device, so things in the probe list, then that means that it's going to be a configuration change to that device, so we call a different API for that, so we call new config. So these call these routines, and you can see in here it's the same processes with the create device. It creates the IoT client, sets up the dev part, and then calls the actual API on the IoT client to do the update device, and it actually bubbles up the promise back up to the next level in the function calls. Same thing for new config, so it goes through, but it calls a different API in this case to modify the config. And to give you an idea what that looks like, so here's my device 2 and my configuration state history. I'm going to go to ourProbes for this device 2, and I'm just going to take out one of the probes that are associated with it. So over here, if I refresh the view into the configuration history, we can see it here. Config 14 is just being created. And if we look into that in the text, we see that there's now only 2 probes in the probe list, whereas before there was 3. Okay, another middleware function that I put in has a Firebase function was this cron job. So it fires every hour, and what it's going to do is summarize the measurements that are in the Firestore measurements collection and create a measurement summary record for that period. I actually combined two cron jobs in this, or two cron activities. So every hour it does the hourly summary, but if it's the first hour of the day, then it also does a daily summary. So here we see function hourly process that is fired every time, and function daily process, which is only on hour equals 0. And these call a measurements function. So from the measurements TS file that does the summary, it's basically you pass a date object and whether it's a daily or an hourly summary, and it'll do all the work for summarizing it. So let's go into measurements and have a look at the summarize function. So it's receives those two parameters, gets the from period by subtracting the number of seconds for the summary period from the date that was passed. So now we have a from and a to. It then goes out to the collection of measurements and basically collects everything between those the from and the to date. And builds up an array here of measurements so I can process it locally. I sort that array of measurements to put them in device, probe, and measurement type order, so that as I go through them I can drop a summary record as each one of those things change, because we get a summary record for each unique device, probe, and measurement type. And as it's doing that, it's building up this measurement summary array. So there's the definition for that measurement summary array type item. Also, it's building an array of the actual values for the measurements within that grouping of device, probe, and type. And that's used for doing standard deviation, where you can only do that after you've worked out what the mean is, and also for getting the percentiles. Again, you need to have a view of all the values in that grouping to get percentiles for it. So here we go. We start running through the list of sorted measurements for that time period, basically looking for a change in any of these keys, device, probe, or type. If it changes, then it's calculating all the remaining values to be calculated for that grouping, and then dropping a new object into the measurement summaries. If we're still within the group and it hasn't changed, so outside this block, then it's just updating the information. So adding to, well, just updating the device. Actually, this is what happens after dropping the new. So we're still at the end of a group. So this is what happens after dropping the new summary record. It just reinitializes things. Down here is where it actually happens on every item in the group, where it's adding to the count, adding a value to the value array, and adding a value to the mean. And remember, the mean only gets finally calculated up here when we change the group. It then goes and divides the mean by the count. We do one last dropping of the measurement summary. So when we've dropped out the last group, that last group hasn't been saved to the array. So we do the final processing one more time. So I'll probably change these into a subroutines because I do it twice. And that's it, and it returns the measurement summaries. And we go back up to our cron job. So we see when these measurement summaries get returned, it's calling measurements write measurement summary. So this is the routine that takes that array and actually writes it out to Firestore. So we've got measurement summaries out there. We see all the measurement summaries that have been produced. This has been running for a couple of days. So it looks like the cron job's working, and we have a lot more measurements. So the other thing I haven't done yet in that routine will be to delete old measurements. So maybe after 30 days I get rid of the old measurements every time the cron job fires anything older than 30 days. Okay, a quick look at a new function I added to actually create the config.py for a particular device. So it's done with a new component, gets inserted into the device component. So if I click on this, keep it, show in folder, we see that there's a file created called d02config.py that gets downloaded, and if I open it with Notepad, this has the config information for that particular device automatically filled in, including the private keys and tuples. So that is the reason that we're storing the private key tuple with the device, to make it easy to create that config. In the future I'll probably add a function to the ESP32 probe code, so it goes and looks out on the SD card if there's a new config there for that device, and it just copies it as the new config. So that should make setting up and deploying the devices a lot quicker, where I don't have to manually upload the config to the device every time. Just a quick look at the code. So this new component, device config, just creates an HTML link and the HTTP download functionality, so that when I click on that link it produces a file that gets downloaded automatically. And the code behind is here. The actual formatting of the config file, I do use the JSON to make things, JSON stringify, to make things a little easier, but there was some difference between the way Python looks to see values in JSON and what JSON stringify does. So also had to do some replaces to clean things up, but still not a very complicated component to do that.